So a public good is a good or a service which is available to the public to use all the time, that you can't stop the public from using, or not stop very easily. So for example, if I put this video onto YouTube, it's available for the public to look at. Anyone can use it. They can use it at any time. The video sort of doesn't get used up when you use it. It's there to look at again, and there's still as much of the video to start with. And it's difficult to charge a price for it on YouTube. I suppose it's possible, but it's difficult. And also a lot of people can look at it at once. Like if you watch this video, it doesn't stop anyone else watching the video. So those are the main characteristics of a public good. Now, technically, in economist speak, that means it's non-excluded by price. We can't exclude people from watching the video by charging a price. And non-rival means that, well, more people than one can look at the video at the same time, just like you're doing here, and it's non-depletable. You don't use up the video by watching it. Although, because you can go back and watch it a second time, and there's much as available of the video for other people to watch, no matter how many times you watch it. So those are the three things. So characteristics of public good. They tend, in economics in particular, this topic, we tend to look at public goods provided by the government. Okay, but there is this issue here of the free ride. People free ride. Non-payers get the benefit. So in the case, even if you haven't paid for the video, I suppose you guys in a sense have, but if you haven't paid for the video, you still get the benefit of watching it. Okay, so that's the characteristics of public good, and here are some examples. Of course, I mentioned the YouTube video, but also street signs, road, public television, radio, are all examples of public goods. So and the idea is, once it's provided, very difficult to stop others using it. However, let's have a look at a specific example here, and this is a road or a bridge as a public good, and let's just go through a few things here. So you'll see that this is up the left axis you've got your marginal benefit, marginal cost, and we're mainly looking at marginal benefit here, and we're pretending that there is a fixed cost. Once that's gone, we don't have to worry about the actual cost of the bridge, but someone has to pay for the bridge. So there's an issue here. Now you'll see here the price is $6. Now the first person to drive on the bridge, the actual price of the bridge, the value to them may be $6, and the 18,000 person may have no value to going across the bridge, so zero value. And you'll see the bridge has a capacity probably here, although it's not stated on here, about 22,000 rides. And so what you've got a bridge is that will a carrying capacity of maybe of 20,000, but 18,000 people want to use the bridge, and in this situation they don't have to pay for it. So what's the actual value to these people of having the bridge there? And if this is 18,000 a day or 18,000 a month, I'm not sure, doesn't matter. But what's the value? Well, it's the area of this marginal benefit curve down here, which is similar to a demand curve, the area under that, and that's given by the area of this triangle right here. So how much is that worth? Well, half the base times the height. So if I went 9,000 times 6, half the base, 9 6 is $54,000. So the benefit to the consumer or drivers is $54,000. That's actually the value of it. So what would happen? What would happen, if the governments or the council? So this is a good example, like Auckland Harbour Bridge. They want to put another bridge in. What's the value of sticking it in? And the question is, how do you pay for it? Now, you can pay for it straight out of taxes. And that's great. And if you do that, then the people that drive across it get $54,000. Those people. But sometimes these projects cost a lot of money, and you might want to introduce a user pay system. So if you introduce a user pay system, you might decide to charge a toll, and maybe charge $2 going across a bridge, and it might not cost much money to collect it. Sometimes you see people with toll collections collecting money, and sometimes they might just be able to record and charge $2 to everyone by having some sort of computerized number plate reader when they go across. So the assumption of non-excludability by price is a bit of a relaxed assumption here. But let's say they charge a $2 toll, and that's given by a line like that. What that then means is that you're going to have 12,000 people cross the bridge, because those who think that the trip is worth less than $2, like $1.95, are not going to go across the bridge. They'll stop travelling across the bridge. So only 12,000 people will travel across the bridge. And that's great, but there is a cost to society of doing it. The best option for society is to have the bridge and not charge for it, because the benefit that accrues to people is greatest when that happens. However, if you have a look here, you'll see that nonetheless the government gets a toll, okay, that's given by the blue area, and the yellow area is now the remaining benefit to consumers. So how much is each of these things? Let's have a look. If we go back again, half the base times the height, the benefit to consumers in the yellow is half of 12, or 6, and a $4 distance along here, 6 4 is $24,000. So consumers still get $24,000 benefit, and of course if the bridge is not built, they don't get that. Okay, so it's not as good as the previous situation for consumers or for everyone, but the bridge gets built. Okay, and the toll revenue is 2 by 12, the area of that rectangle, that blue rectangle there, $24,000. And this little light shaded blue bit is the bit that disappears. It actually disappears basically off the screen. So what do you do here? Well, what you have to do here is you have to work out what do people miss, and that's your dead weight loss. Sorry about the way it's come up on the PowerPoint, but that's $6,000. 6 by 2 gives you 12, and half of that, half the base times the height, gives you $6,000. So that's probably one of the more important diagrams you need to know. So have a look at that, make sure you know it, and if it came to an example in an assignment, you'd be expected to reproduce a diagram like that. Thanks very much.